The title of this video is Appraising Geologic Theories. I've been handed two different scientific theories from two different geoscientists as a geology student for review and appraisal. I've decided to ask my geology faculty member for help with understanding these proposals because they are my first time doing it and different from what I previously learned in class and my current understanding. So the faculty member that I asked for help wants me to create a memo for him outlining the two different proposals and my thoughts on them so that when we meet to talk about it, we both have important information to guide the discussion. Here is the information that I have put together for the presentation for the faculty member that he asked me for. There are 2 to 3 different theories for how the land masses on Earth got to be how they are today. And my understanding about this whole story that I'm presenting with this information outlined here. When the Earth was first formed, 13 billion years ago or something like that, of course, it began as all matter began as nothing. And then due to gravity and atoms and molecules, etc., reaction, combustion, mixing everything. Eventually, over these 13 billion years, we had the core of the Earth, and then with all those reactions, we had the inner core, and then we had the outer core. And then we had, on top of that, a asthenosphere or something like that. And on top of that, we have the lithosphere. So the asthenosphere is below the lithosphere and above the Earth's outer core. The lithosphere is the continental crust of the Earth, because the Greek word litho means rock, and that is composed of rock. And of course, we have the hydrosphere, which is the water part of the geosphere. So after explaining the basic origin of how the Earth formed, in the early 20th century, which is the 1900s, we had a German meteorologist named Alfred Wegener, whom I will provide a photo of in the slideshow video presentation. He is correlated with the continental drift theory, which was the original first one that he had proposed in the early 1900s. And of course, as with any free thinkers outside of the box, scientists who have the bravery to speak out and suggest theories, hypotheses, new ideas that have never been heard before, geniuses really, they're rejected, they're scoffed at, they're not accepted. Okay, so what ended up happening was the plate tectonics theory. Continental drift theory turned into the plate tectonics theory. Okay, so the parts of the similarities and the differences that I have compared here, continental drift and plate tectonics. The similarities are that they are both associated with the German meteorologist Alfred Wegener. The differences are that continental drift was proposed in the early 20th century and plate tectonics was proposed in the 1960s. The similarity is that both land masses move in both theories. The lithosphere is associated with continental drift, which is the outer crust. The asthenosphere is correlated with plate tectonics, which is just below the lithosphere. And plate tectonics are said to be the cause, and continental drift is said to be the effect. So with the colors that I used here to denote, the red is the similarities and the blue is the differences. So to present a little more understanding of where I'm at, when other scientists proposed the theory of plate tectonics, building on the foundational ideas for continental drift theory from Alfred Wegener, they said, okay, well, in the continental drift theory, Pangaea, which was one piece of land, eventually, after millions of years, moved apart and spread apart, and now we're kind of floating all these different continents on the ocean that look like puzzle pieces that fit together. And so, you know, they were curious, like, how did they get positioned where they are? And this is how the theory of continental drift came about. So they said that plate tectonics, after they looked into continental drift about the puzzle pieces, so what happened was there were faults. There were earthquake faults based on the core, which is boiling and causing pressure. Over time, we have different boundaries, plate tectonic boundaries. Plate tectonics are the locations on the earth where earthquakes happen and volcanoes are located that cause earthquakes, underwater, etc. There's three different types of boundaries. There's a divergent boundary, convergent boundary, and a transforming boundary for the plate tectonics we're talking about. The divergent boundary means the plate tectonics diverge and move apart. This would explain how Pangaea turned into the different continents we have today through divergent boundaries, as well as a big mixture of convergent boundaries compared with divergent boundaries moving apart. Convergent boundaries are the lithosphere, Earth's crust plates, colliding. So they're moving together. And the third one, transforming boundary, is really self-explanatory, which means it results in the shapes of the land masses changing shape, which is why it's transforming boundary. And based on all of these theories, okay, at the bottom I noted, this has not stopped. This is still happening today, all of these phenomenons and processes and actions of the earth, okay? In 100 million years from now, based on the process of the rate of speed that this is manifesting, we could possibly very well have even new continents in 100 million years. Okay. So the new theory that the Earth's core may also be solid with liquid patches. The Earth's core has two parts, outer and inner. Okay, so the inner core of the earth is solid, made of iron. And the outer core of the earth is liquid, magma, like lava. And, you know, I will get more into that in my 350 to 7 word memo essay coming up here in the next slide that I will be narrating with captions, in which I detail the differences between continental drift, plate tectonics in detail, and the ideas from our university library's Hidden World article, which I am excited about watching. In the memo, I will briefly summarize each theory. I will identify similarities and differences between theories, as I have done in the paper I showed you here. What are points of agreement and disagreement between the theories? Describe any questions I might have about each theory. What makes sense and what doesn't make sense? Describe the strengths and limitations of each theory. Include references in APA format in text and ending. This includes pictures right here. This is for the picture of Alfred Wegener, the scientist responsible for these theories. And actually, this is the picture, number 2. And the first one is a reference that I will cite in the next slide, memo essay about the core of the earth. Let's get started.